Yes, so hello everyone. My name's Martin Cryan. I'm a professor in electrical engineering at the University of Bristol, and I'm the program director of a new MSc that just started this year called Optoelectronic and Quantum Technologies. So I'm going to tell you a little bit about it, and happy to answer any questions you've got about our new program. Yeah, so many of you probably know this already, but let me tell you about it. You know, the quantum technologies are an amazing set of technologies that kind of grown out of the realm of physics, but now they're pushing into engineering, and they're kind of already revolutionizing the world, but they're definitely going to change the world a lot in the next 5 to 10 years. So we're going to have different types of computers. We're going to have ultra sensitive imaging systems, and we're going to be able to sense things that we've never been able to sense before. And a lot of these quantum technologies are based around controlling photons and electrons. And that's like at the heart of this MSc program, you know, bringing these two things together. That's the kind of optoelectronics side of things. And what this MSc is going to do, it's going to try and give you a lot of the fundamental quantum knowledge that you're going to need, but we're linking that to all the engineering skills that we think you're going to need as well. So we think we're reasonably unique in these kind of MSc programs. In the first of all, we're in an electrical engineering department, which I don't think many of them are, and there's a lot of focus on things like, you know, VLSI chip design, photonic integrated circuit chip design. So we're sort of coming from electronic integrated circuits and going into photonic integrated circuits with sort of for quantum applications. Yeah, and so the way we've designed this program is it's a new sort of approach that we're taking in the whole of Bristol University. It's using these things known as pathways, so that when you apply for the program, you need to choose one of these 3 pathways. So we don't traditionally, our MSc programs would have sort of optional units where you can mix and match different units and choose which you want to do. And whilst that gives students a lot of flexibility, it doesn't really guide them as to which sets of units make the most sense. So what Bristol is doing more these days is pre-grouping these units together and saying we recommend you choose these groups of units. So, and this is what we've set up. So we've got quantum photonic chip design, we've got quantum networks, and quantum information technology. And these are sort of linking into the strengths that we've got at Bristol. Many of you probably know already about this sort of photonic chip design that we've been doing at Bristol for a long time. Basically using the silicon insulator platform as a building block technology. And what's great about that technology, it's very established. If you get your circuits right, you know, they will work. So yeah, there's a large activity on that in Bristol. What we've also got in Bristol is a very large, what you might call classical communication networks group, called the High Performance Networks Group. So, and we're doing more and more work linking with that networks group, where we're putting quantum telecom systems and we're embedding them and using conventional telecom networks to do that. So we've formed this particular stream, which links with that group a lot, and we're calling it quantum networks. And then the other strength we have in Bristol is there's a lot of quantum information theory. There's a number of theory groups here doing sort of quantum information science. And so we formed a 3rd stream there, which links into the sort of maths department and the physics department too. So those students that are more interested in the theoretical side of things, sort of, you know, quantum algorithms, that kind of direction, I would recommend that stream. Yeah, and so the program structure for MScs in Bristol are sort of pretty much uniform across the whole university. And you study what's called 180 credit points. So that's what you need to achieve an MSc. In fact, I think it might be uniform across the whole UK. And of those 180 credit points, 120 credit points are taught units and 60 credit points are research project units. So on here we've got, in this program, we've got 10 what we call core technical units, which I'll come to in a minute. And then we've got this one unit, which is a sort of newish unit that we really kind of like. It's called Engineering Research Skills. And what it does, it prepares you for your research project. So this program, it would start in October. the whole program starts in October. You get allocated a research project in December. And then in February, this unit starts where you look into your project, you do a literature survey, you talk to your supervisor about the project, and you make a project plan. And then this research project starts when this one finishes. So this one starts in June and runs to September. And so there's a nice linking between, you don't jump straight into this project, you have a whole preparation for 2 or 3 months to understand exactly what your project's about. Yeah, so these are the 6 core units that span across all 3 pathways. And so I'd say probably the 2 core, I'm a little bit biased, you know, I'm in the photonics kind of research area. So I like these 2 units. I teach this one, Optoelectronic Devices and Systems. I teach half of this one and half of this one, Advanced Optoelectronic Devices. So this unit is the first unit, you know, if you haven't done much photonics before, this is like, you know, from the ground up, introduces everything about photonics, optical fibers, lasers, photodiodes, modulators, integrated circuits, integrated waveguides, Maxwell's equations, all that kind of stuff that, you know, you may or may not have done in your previous degree. And this one introduces all those concepts. And this one follows on in the 2nd semester, you know, it starts in February time. And, you know, takes this one a little bit further, goes into things like nonlinear optics, all the kind of stuff all the maths that you'll need when you start doing a lot of the quantum material, that you'll need a lot of the information in this unit. We also think a really important part of a lot of quantum technology is RF engineering. And this is often what's missing from physics degrees. When physicists start doing quantum engineering, they often haven't got the appropriate background in, you know, things like designing 50-ohm transmission lines to deliver microwave signals to trapped ions and also that, and, you know, sort of quantum dots are also different types of technologies. And this again starts from the ground up, explains all about RF engineering, impedance matching, some of the key skills that you need. What else we've got on here? Yeah, we've got another optical communications unit here. This is more sort of systems level. So this is taking the output from these 2 units and leads into this one, where there you're talking about system design, you know, sort of WDM type systems. How do you design them? How do you correct for problems of dispersion and loss and those kind of system level things? And this one, the other thing we do a lot of in Bristol is digital signal processing. And that's becoming more and more important in quantum technologies as you have more and more control signals to deal with. You know, you can't rely on soldering these boards together and doing it kind of manually. It's got to be, you have control chips, which electronic control chips, which are controlling the quantum chips. In this unit here, you'll learn all about how to understand how those chips work. And then this is the first sort of introduction to quantum device engineering, you know, quantum engineering 101, if you like, where we introduce concepts of superposition and entanglement, but in a very sort of engineering focused kind of way, and prepares you for the more advanced units that are sort of more on the sort of physics side of things. I should keep an eye on the time here. Okay. Yeah, and then these are the units that make up the 3 pathways. So yeah, so this is the photonic chip design pathway. So you'll learn all about integrated circuit electronics, you know, but conventional ones, because more and more what we're seeing in Bristol is that we're going to be attempting to integrate both photonic integrated circuits and electronic integrated circuits on the same piece of silicon or gallium arsenide or silicon germanium. And these technologies are going to come together more and more. So this is the sort of foundations of integrated circuits. And that leads into VLSI design, where it's a very practical focused course, this one, where you're actually using industry standard design tools to, you know, lay out full chips, understand how these chips are designed from the ground up. And yeah, the other nice facility we've got in Bristol is a great class 1000 clean room, full of state-of-the-art equipment funded by large government grants where you can do things like e-beam lithography, wet and dry etching. You know, you can, again, make devices from the ground up, starting from wafers. We do all sorts of things in our clean room. And this unit prepares you for that kind of activity. In fact, this year, we're going to try to get foundry access as part of this unit. So we're going to try, it's not absolutely confirmed yet, but we're planning to effectively get student access to one of the UK foundries. And so in this unit, you'll be taught how to lay out a photonic integrated circuit chip, and it's going to be bespoke to you. And we think the turnaround is fast enough that you might even be able to measure your own chip within the same academic year. So that'd be an amazing turnaround if we achieve that, and we hope to. And then this unit is quantum system engineering. So this is trying to understand quantum technologies, but more at the systems level, because that's what a lot of engineers are required to do ultimately, is you rely on the physicists to confirm that these devices work properly. They build models of these devices that you then use to design your full systems. And that's what's happening in this unit here, where we're trying to help quantum engineers to design large, complicated systems. In the quantum networks stream, you can see that we're very focused on our networks unit. So we have a number of other MSc programs that we've been teaching for many years that are sort of led by world experts in this field. We have a research institute called the Smart Internet Lab, about 150 researchers and academics that work in this space. So this unit, again, introduces you to the whole concepts of networks. We do a lot of work with data centers, and this unit prepares you for that. This explains how optical networks relate, you know, because there's many different types of networks, right? Not just optical ones, but this focuses down on that. And then we have an advanced networks unit, which, you know, brings all this understanding together. Yeah, and then this is the sort of theory-related stream, if you like. So we called it Quantum Information Technology stream. So we have units taught from the maths department, quantum information theory. And this is an undergraduate unit that we thought this would be good for engineers on this stream. So this would give you the basics of quantum physics, sort of a third-year undergraduate module that will help you with sort of notation that's used if you haven't come across it before, and give you a great grounding for these other more theoretical units. And then there's, again, from the maths department, a quantum computation unit that introduces all the concepts in there and prepares you for that kind of algorithms type direction. And then again, you do this quantum system engineering unit, which appears on these two streams. Okay. And yeah, so really the high point of your MSc program, as far as I'm concerned, is your individual research project. So this is your opportunity to try and tackle a real research problem. So we don't just make up stuff for you to do for 3 months to keep you busy. We genuinely try and give you a real research problem. Typically, you're working embedded within one of our research groups, typically working with a PhD student, helping them on real problems. And this year we've got around 30 project ideas, which you get to select from these 30. As I haven't mentioned earlier, that so our MSc has 14 students on it this year. So we try and give, you know, at least double the number of projects to choose from compared to the number of students that we have. Yeah, and we're really lucky. So we've got a lot of industrial collaborators in Bristol, and a number of them are have already signed up to host project students. So in the normal world, that would mean you'd go and work for them during the summer, June to September. That's obviously a little bit more difficult at the moment, but there are advantages to that in the sense that a number of companies who are not based in the UK are expressing interest. And in some senses, it can be easier to do these placements if you don't have to worry about, you know, moving and renting places and things like that. And all companies are now working out how to work remotely. And so these MSc projects can fit quite nicely into that remote kind of working scheme. This is a little picture of KET Lab. So this is the main sort of quantum research activity within Bristol, and there's the URL link down there that you can have a look at. But there's many things going on inside that. And I should point out there's a sort of in parallel with this MSc, there's a PhD program called the Doctoral Training Centre, which is one of the ways that you can do a PhD in the UK now. And we've organised this MSc program such that if you do really well in this program, you could apply for the PhD program. You obviously can't, you're not guaranteed to get accepted on the program because we have many hundreds of applications from all around the world every year. But, you know, if you do really well on MSc program and you get a really good project mark, that means, you know, we know exactly who you are, what you've done in Bristol. So I would say you might have a great chance of getting funding on that program. Yeah, so here's just some, these are actually the projects we're about to release to students in a few weeks' time. So these are industrially sponsored ones. We've got a number of spin-outs in Bristol. This is one of our older ones called Ketz Quantum, and they're interested in things like ASIC design for QKD and quantum random number generators, quantum networks, and they're interested in a lot of validation of devices and chips they're actually making. They're based in Bristol, just down the road from the university. Airbus is another big company in Bristol, not a spin-out, obviously, and they're really looking at the long-term vision for what quantum can give them. And so these are some exploratory projects they've given to us that they'd like an MSc student to look at, about using quantum in aviation and you know, single photon sources and how you can interact with them. And then there's another spin-out control that is much more focused on electrical engineering, and they're interested in developing control systems for quantum photonics. And here's some of the more academic projects that we're offering this year. A whole range of different things from, you know, free space, quantum comms and satellite comms, photon generation in barium titanate waveguides. This is my one here. I'm interested in what are called triple resonant cavities. You can do things like full wave mixing in these cavities, and potentially they're a very efficient way of creating photon sources. So I think, you know, I think one of Bristol's nice points is that we have a very wide range of activities, from fundamental semiconductor physics, looking at NV sensors in diamond and other materials, all the way to, you know, global networks, quantum networks that we're looking at. I should try and wrap up in a minute now. This is just an overview of the structure of what goes on in Bristol. I'm in the electrical engineering department, but we work very closely with the School of Physics. We've got a number of joint appointments between the two departments. This is the Smart Internet Lab, which I mentioned earlier. I'm also a part of that research group, if you like. And then within the Smart Internet Lab, we have a large, basically RF and wireless comms group. This is the networks group that I mentioned earlier. And this is a photonics and quantum group, which I'm part of, which links into KET Labs, which it links back into the School of Physics. And we've got a large number of academics and researchers with some amazing facilities. Yeah, just some sort of nitty-gritty things that the sort of in terms of entry requirements, typically require what's called an upper second class honours degree in the UK. So we call that a 2-1. And you know, from wherever you are in the world, we can work out what the equivalent for that is in your system. This program, we think it's not really suitable for students from aerospace, mechanical, civil or automation engineering. So we don't recommend you applying if you're from that background. And we can look at lower classes of degree. Sometimes if you've worked for a number of years, we can use that as to balance off the fact that your degree might not be a 2-1, for example. English language is really important, and we use a system called IELTS in Bristol, and we recommend, well, almost kind of require that you have an average of 6.5, but there can be some negotiation around that, but really that's the minimum. And yeah, so you've got a long time to think about it. I'd apply early as you can is my recommendation, but you know, we can give conditional offers. You don't need your degree results. You get conditional offers, and then that can become unconditional once you get your results in. But so that's probably the latest you want to think about applying. I think I've got One more? Yeah, just think about careers. I think, that this is an amazing industry that's exists and is rapidly growing all the time. And I think what we've just tried to create in this program is to set you up for these careers. And I mentioned this earlier. This is the doctoral training program that you can link into. If you do really well on this program, you can make an application. There's no guarantee, but I think it's certainly one route. A lot of the big blue chip multinationals are looking this. Airbus is one really good example. And I imagine that all of these large companies are looking at quantum computers, and currently they're typically recruiting PhD students, but they're going to be at the point where they want master's students, and they want to train them up internally to do exactly what the company needs. Rather than taking a PhD student and retraining, they want to train from the MSc level. And there's just probably hundreds of quantum startups now that are all soon will be looking for this master's level kind of training. And in Bristol, we're also lucky. We've got what we call a quantum entrepreneur program called QTech. And so, if you did the masters and you came up with a great idea, patented it, there's all sorts of ways that you can commercialize what you come up with. Okay, that's it from me. I wonder how I stop sharing.
Thank you, Martin.
Okay there.
Any comments or questions from anyone? It's easier to ask now than set up a meeting through email someday down the road. Well, for my part, I was curious. You've got the 3 pathways there. I found that pretty interesting. You got a good net there, if you want to call it that.
I think so. Yeah, we're sort of trying to keep it quite broad, and because there's so many different aspects of engineering that that quantum technologies need. My particular background is sort of RF and photonic integrated circuits, but I think there's a whole range, software engineers and
well, the quantum networking was one that caught my eye. I mean, there's really not much evidence that if someone, let's say, for example, a student, saw potential in quantum networks, there aren't really many options right now necessarily specific towards that.
And we're really lucky that, we've already got, funded large grants on putting single photons down conventional networks. So it's great opportunity for MSc students. You can get embedded in those type of research projects and really start to understand what all the problems are.
Yeah, it's roughly, you've got the 14 now. Just out of curiosity, what's the distribution? Have they selected pathways yet, or?
Yeah, they have. The majority have gone for the photonic integrated circuit pathway at the moment. And I'm kind of happy with that. That's the one that I most actually, but there we go. Because we want to we've got such a great clean room that we want to try and get students in the clean room. It's a little bit difficult at the moment, but we can certainly train them up. As I said, for like circuit layout, explain how you do e-beam lithography and all that kind of stuff, such that we think hopefully, middle of next year, later next year, when the projects actually start, we're hoping students will be able to get in there and experience real clean room stuff.
Yeah, this is not exactly a good lab year. So.
No, but we've got great simulation tools. I think, my research is really around simulation tools. So I'm kind of, I can get by okay.
It's one of the reasons I stay with software. It travels with me no matter what. So anybody, questions, comments?